An embedded system is an autonomous electronic and computer system with the goal of executing a well-defined task in real time. Here we see the first difference from a PC, which is versatile because it can run many types of applications, whereas an embedded system only performs a dedicated function. Furthermore, embedded systems are often invisible to the user because they are integrated within a device that itself serves a function. For example, a microwave oven, an airplane, a washing machine, etc. Domains of embedded systems are primarily found in the following areas. First, we have general computing, similar to PC applications, but integrated into an embedded system, such as smartphones, tablets, etc. Then, systems control, such as motor control, automotive applications, aviation and navigation systems. Also, signal processing, with examples like radar, sonar, and video compression. And finally, communication and networks, involving information transmission, telephony, and the internet, for example. So, as you can see, there are many embedded systems. Today, embedded systems far outnumber computers in terms of quantity. An embedded system typically consists of a microcontroller that solves a specific problem, often subject to time and size constraints. A microcontroller is an integrated circuit that combines essential computer elements that includes a processor to provide computing power, a central memory, often limited, containing the program and data, sensors acting as inputs to receive information, such as temperature, vibration, humidity, proximity, pressure, or contact, and actuators or outputs that allow the embedded system to perform actions on the external real-world environment. These can include LEDs, display screens, speakers, alarms, or a combination of these, as seen in an airplane cockpit. Finally, embedded systems are equipped with communication, means that enable them to communicate via the internet with external applications and end users. This is the phenomenon of the Internet of Things, or IoT. It's important to note that there is a significant difference between embedded systems, based on the device in which they are embedded and the complexity of the task they perform. On one hand, there are small-scale embedded systems with very simple hardware and software sufficient for basic tasks, like a coffee machine that transforms your coffee capsule. On the other hand, there are advanced and sophisticated embedded systems found in devices like airplanes, designed to facilitate piloting and improve safety. The design of an embedded system typically depends on the characteristics and constraints of the device in which it is integrated. This includes considerations such as weight and size, program size and required execution time, especially for embedded systems with basic hardware, the appropriate hardware to run the software, energy consumption, optimized based on the size and complexity of the embedded system, continuity of operation, which requires embedded systems to withstand harsh external conditions such as vibrations, shocks, temperature variations, and weather. And finally, manufacturing costs, determined by the aforementioned constraints. Thanks a bunch for tuning in. To stay in the loop with all things tech and computer science, be sure to click that subscribe button and ring that notification bell. Goodbye.